Hello. In the last session, we have talked about kinematic links and joints. We have classified links, or we have seen the types of links like rigid links, flexible links and fluid links, and joints, binary, ternary, quaternary, like. So now we move on. We move on to kinematic pairs. So we have seen when we are joining two links together with the help of a movable joint, we are calling it a kinematic pair. Now this kinematic pair are, again, we can classify them first according to the nature of contact, then according to the nature of mechanical constraint. Constraint means restrictions. And third, we categorize according to relative motion. So whatever we are to, according to nature of contact means the nature of contact between the two members which we are joining. According to nature of mechanical constraint means how we are forming, how we are providing the restriction to the two members. And then according to relative motion, what is the relative motion between the two members. That is how basically we are classifying the kinematic pairs. Now in nature of contact, when we see the classification, according to nature of contact, again we can sub classify them, or maybe the type as lower pairs and higher pairs. Now when the contact between the two members or the two links where we are forming the joint, if the contact is a surface contact or area contact, then the pairs which are formed, they are called as lower pairs. And in case of higher pairs, the contact between the two members is a line contact or a point contact. Now for this, if we quote example, like if this is link number 1, let us say this is link number 1 and this is, my other hand is the link number 2. So I am forming a pin joint. So what I am doing, so I have to form a pair between these two links, as let us say this, so that this forms a pair. Now I bring these two links together and place a pin. So the contact between these two members is of surface contact, then it is going to form. So let us say this is one link and I am joining another link to this link with the help of a pin joint. So here you will see the contact between the two members is area contact or surface contact, or maybe like we have seen the example cylinder and piston. Inside the cylinder, the piston is in contact with the cylinder through an area. So that contact is again area contact. So such pairs will get into the category of lower pairs. What are higher pairs? Like in case of ball bearings. So say this is the shaft, and the contact between this shaft and the hole, it is in terms of pure point contact. There are balls, or instead of balls there can be roller. Instead of balls, if there are rollers inside this, then the contact between these two members will be of line contact. So if there are balls, so like in case of ball and socket arrangement, it will be a point contact, and if it is a roller, then these will be line contact. So this gets into the category of higher pairs. So when we say higher pairs, you may see the surface contact is reduced, so the friction will be lesser in such cases, whereas in case of lower pairs the friction will be quite high. Now second case or second classification, what we have said is according to the nature of mechanical constraint. Constraint means restriction, how we are providing the restriction when we are forming a pair. In this, the first case, or we call this as a closed pair, and second we call it unclosed pair. We don't call it open pair, we call it unclosed pair. Now what is a closed pair? Now if, let us say, I quote this example, say this is link number 1, which is having a cross section rectangular, and I have a rectangular hole in this rectangular block, and the other member is of again rectangular cross section, which is put inside this one. So what is happening here, the arrangement, the mechanical arrangement between these two pairs is so that in whichever direction I apply force, the motion of this body will be always the way it has been placed to it. So it is absolutely fixed or constrained. So if I want to in a case, if I want to have another motion, ultimately I'll have to break up this thing. So this is how we are providing, by virtue of the arrangement itself, the motion is definite. So such pairing, or maybe in case of another, so that will come into the example of a closed pair. Now what is an unclosed pair? Example can be a simple cam follower arrangement. This element is called as cam. We will be studying cams in details. So now this member is called as the follower. Just try to imagine this situation, how motion is getting executed. See, when I rotate this member, so this is going to push this follower upwards. So when this rotates, the follower will be moved upwards, right? So after certain time, when this comes back, it will come back. Now how it is going to come back? Due to its self weight. Now if I turn it very fast, chances are there that this member is going to fly off, right? So in such a case, so there is no mechanical constraint provided to this arrangement, this sort of pairing. Now such pairs are called as unclosed pairs. I can make it a closed pair if I provide now a spring. So I press every time the follower onto the cam, so I am providing a mechanical force to it. So in that case, it will get into the category of closed pair. So that is how a closed pair and unclosed pair are classified. And the third is according to relative motion. So according to relative motion, if we see, there are number of types. So first is called as a prismatic pair, or this is also called as sliding pair. The second is cylindrical pair. Third is a revolute pair. Fourth is a screw pair. fifth spherical pair, and sixth is a planar pair. Now what is a prismatic pair or sliding pair? Now according to relative motion, so it suggests the relation between the two members is of sliding nature. So like I have quoted the example, so if this is link number 1 and there is a cross section of rectangular, so this link number 2 inside this one is going to have only sliding motion, right? Now here as well we will try to understand another thing called as degree of freedom. Now if there is one link in the space, it is having a freedom to move anywhere. The moment I form a joint, some of its motion are getting restricted. Fine. So maybe this can move now only in this fashion. So rest all its motion are restricted or constrained. So that means it is having a freedom to move only in one direction. So that means in this case, if you see, the cross section is rectangular, so I cannot turn it or twist it inside this hole because the cross section is such. So it is having only one scope of movement, which is linear motion and which is sliding. So I can describe the equation of motion with the help of only one variable, let us say x. So it will have only the one variable can express the equation of motion. So it will be having, in this case I'll say that the degree of freedom of this pairing of sliding pair will be of degree of freedom 1, right? So these are called as the prismatic pairs or sliding pairs. Now if I just modify this same example, instead of a rectangular cross section, if I make this cross section a circular one and I put a circular rod inside it, right? Just like a latch of a door, if you have seen. Now in this case, if you see this arrangement, this is link number 1 and this is link number 2. So in this case, the link number 2 can slide inside, so it is having one variable delta x, right? And another motion can be, it can turn inside it. Just try to remember a latch. So in this case, what will be happening? So there can be another variable as well. But if you see, both these motions in this case or in case of a cylindrical pair, they are independent. I can turn it here itself, I can turn it and slide it inside the hole, or I can simply slide it without turning it also. So these two variables, they are independent. So both these motions in this case of cylindrical pair will be independent. So I may say that the degree of freedom between these two is 2, because there are two independent variables which needs to explain the equation of motion. Now if we see the third case, that is the revolute pair, simply in this case again we modify the same joint. So it is the same joint, there is a rod inside this link number 1. Now as in case of a cylindrical pair, it can turn, it can slide, fine. Now if onto this rod I provide a collar like this, so now at the both ends, so if you see this in this fashion, so this is the rod, so I provide a collar at both the ends. Now this can turn, this can only turn, but it cannot slide inside this hole. So I have restricted the sliding motion in this case. Only this member can only turn about its axis. So it is having only one variable, so let us say delta theta, to explain its motion, and this is forming a revolute pair. So in case of revolute pair, the degree of freedom will be what? Only 1. The degree of freedom will be 1 for this pair. And what is the type of motion involved in it? It is only rotary motion. Hence these are called as revolute pairs, as well as these are also called as turning pairs. Now again the modification, if you see the fourth, so we have seen prismatic, cylindrical, revolute or turning pair. Now we talk about screw pair. Every one of us have seen a screw. So in case of a screw pair, there are threads, right? Now when this is into let us say a nut, you will see that, of course, when I turn this, so when I turn this member, say this is link 1 and this is link 2 of the pair, so I turn the link number 2. In this case, this link number 2 is going to rotate, but by virtue of its arrangement, in this case it will as well move forward. So see, in this case it will come into the category of closed pairing, because when I turn, it will move ahead because its arrangement is such. So it is forming a closed pair. Whereas in case of a revolute cylindrical pair, if you see, I can call it a open pair, right? So here it is. So when I turn it, so it is going to move ahead. So it will definitely have a linear motion. This link number 2 will have linear motion, as well as this link number 2 will have rotational motion, say delta theta. But in this case, these two are not independent, they are dependent on each other. So if I turn by theta, I can predict or I can tell what will be the linear motion depending upon what is the pitch we have provided, right? So only one variable needs to understand what can be the motion. So though apparently we see that there are two motions in this link, but the degree of freedom of a screw pair, or this is also called as a helical pair. So screw pair or helical pair will have a degree of freedom 1. Fine. So then we move on to the next, which is a spherical pair. Now spherical pair is, see, screw pair, so the pitch and they will be having surface contact, so that will come into lower pairs classification, and we as closed pairs. Now if we see spherical pair, so the example is a ball and socket arrangement. So ball and socket arrangement, so say this is link number 1, right, and this is link number 2. You must have seen a pen stand, right? So maybe this is a pen stand in which I can put a pen, right? If you see, now here it can move about this axis as well as this axis. So, and all these motions are rotary. There is no linear motion, right? So these motions are rotary motions. So like example, the ball and socket. This is one axis, so it can rotate about this axis. Second axis is this, so it can rotate about this axis. Fine. Third is this, it can rotate about this axis. The motion is rotary. So there are 3 variables. Let us say delta theta, delta phi, and say delta xi. There are 3 independent variables which are all rotational. Fine. And the final one is a planar pair. Now planar pair, they are extensively used in case of robotics. So maybe this is the member. So this is link number 1, and let us say this is some link number 2 kind of R. So in this case it can slide in this direction, let us say in X direction, and it can slide about this direction, let us say Y direction, and as well it can turn, so delta theta. So in this case again, what is happening? So 2 independent motions are linear and 1 independent motion is rotational. So again they are all independent, so it will be having a degree of freedom 3. So that is what we have seen in today's discussion. So if we just summarize, so simply if we want to summarize, so motion, if I want to talk about motion and degree of freedom for these, in prismatic pair motion is sliding or linear, having degree of freedom 1. In case of cylindrical, the motion is rotary and linear, independent, so it is having only one variable, so degree of freedom 1. It is having two independent variables, degree of freedom 2. Revolute pair, only rotational, so it is having only one degree, variable, so degree of freedom 1. In case of this, it is having rotational. In case of screw or helical pair, rotational and linear, so it is having delta x or delta theta, though motions are 2, but degree of freedom is 1. In case of spherical pair, all motions are rotational motions, independent delta theta, delta phi and delta xi. All these rotational motions are about 3 axis, they are independent, so degree of freedom 3. It is having 2 linear motions and 1 rotational motion, so delta x, delta y and delta theta, but all these motions are independent, so again this will be having degree of freedom 3. So that's all for this session.